Hello everyone, welcome to Artistic Atom channel. I am Fatima and today we will be discussing IBDP Chemistry MCQs. Now these MCQs are based on the chapter Functional Groups and Organic Compound Classification. These MCQs are more exam focused, so this will help you in understanding the different types of questions asked in exam. Okay, so let's get started. Now, the first question is, which of the following shows the correct order of boiling points for pentane, butane, and propane? And these are the options given. So, before going to choose the correct option, let us understand the theory behind. So, when we talk about alkanes, they all are non-polar, okay? And we know that when the compounds they are non-polar, they always interact via London dispersion forces. So, as the molecular the size of the molecule increases, so what will happen, the molecule will have more electrons. So as they will have more electrons, the strength of the London forces also increases. So larger the molecule, more amount of electron will be there, and hence the larger surface area, due to which there will be more stronger London forces. And as the forces increases, it will lead to increase in the boiling point. So we just have to look for the higher or the larger molecule, because the larger molecule will have the more amount of London forces, due to which its boiling point also increases. Therefore, the correct option for this particular question will be B, because here we have pentane, which is the larger molecule than that of butane, than that of propane. So due to which it will have the highest boiling point, then followed by butane, and then followed by propane. So this is how you're going to solve this question. Now, let us also understand, if you come across different questions based on boiling point, how to attempt them. So, well, when we talk about boiling point based questions, there are two things that we always keep in our mind. First is we will always check for the type of bonding and intermolecular forces, and secondly, we will check for the molecular mass and the size. Because as the type of bonding or the intermolecular forces become stronger, the boiling point of that particular compound also increases. So when you have same type of compound showing different type of bonding, you will go for the bonding which is more stronger, because more the stronger bonding, higher will be the boiling point for that particular compound. And nextly, if you have different molecules provided, okay, there you will check for the mass or the size of that particular molecule, because larger the mass, they will have more surface area, which leads to increase in the stronger bonding, and hence in conclusion the boiling point will increase. So this is the conclusion that you will remember whenever you will have questions based on boiling point. That is, if the question consists of same type of bonding, then you will compare their molecular masses and size. If they have different types of bonding, you will go and check for their stronger intermolecular forces, because stronger the intermolecular forces, higher will be the boiling point. Now the next question is, which of the following statement about propanol and propanone is not correct? Now always remember to read the question properly, because sometimes they will write this term, due to which students might choose the correct option and then they will get it incorrect, because they are not asking for the correct one, they're asking for the incorrect one. So always read your question correctly, properly, and precisely. Now they have given these four options based on these two compounds, that is propanol and propanone. So the first option is that propanol and propanone, they both have molecular ion peaks at different mass to charge ratio. Second option is both of them, they have different fragmentation pattern in mass spectrum. Thirdly, they both have absorption in infrared spectrum due to carbonyl group. And lastly, a different fingerprint region in infrared spectrum. So let us check all four options one by one. So the option one given was this, a molecular ion peak at different mass to charge ratio. So let us understand, what do you mean by the term molecular ion peak? So molecular ion peak is nothing but the molar mass of that particular compound. So when we talk about propanol and propanone, they both are structural isomers. What do you mean by structural isomers? They both have same molecular formula but different structural formula. So when we write the molecular formula for both of them, this is what we get. And when we take out the the molecular mass out of it, we get this particular value, that is 58. So we get to know that both of them, they have same molar mass, and when they have same molar mass, they both will have same mass to charge ratio, and due to which we will get molecular ion peak same at the same point for both the structure. This means option A is absolutely incorrect, because it is stating that propanol and propanone, they both will have different molecular ion peaks, but it is not. Since they both have same molecular mass, they both will have same molecular ion peak. So the correct option is A. Now let us understand why other options are correct. Okay, because we have to choose the incorrect one. So the option B given was this different fragmentation pattern. So when we talk about fragmentation patterns, always the compounds having different structures will have different fragmentation patterns. Why? What's the reason behind? Because when we have different structures, they break apart differently, and as they break apart differently, they both will have different fragmentation patterns. So in conclusion, this option given was absolutely correct. Now, the next option was this IR absorption due to carbonyl group. Since we know that aldehyde and ketone, they both consist of C double bond O, that is nothing but the carbonyl bond. Hence, they both will show carbonyl peak in IR spectrum. Hence, this option was also correct. Now, the third option given was this different fingerprint region. So, fingerprint region completely depends upon the entire molecular structure. Okay, so it depends upon the structure. So since we know that propanol and propanone, they both have different structures, because they are structural isomers, they both will show presence of different fingerprint regions. Okay, so this option was absolutely correct. Okay, so in exam, you will remember these things, that if the same molecular formula is provided for the given compound, then they will have same molecular ion peak. But if they have different structures, then surely they will have different fragmentation patterns and different fingerprint regions. Okay, so these are the key tips that you should remember whenever you are attempting such questions. Now the third question is nitrogen trichloride has the formula NCl3. A sample was found to contain only nitrogen 14 and chlorine atoms with mass numbers 35 and 37. This means we have isotopes of both the isotopes of chlorine. So we have to select which of the following is an incorrect ion and mass charge ratio responsible for the molecular ion peak found in the mass spectrum of nitrogen trichloride. So here we have provided with all the different ions that may be possible during the study of mass spectrometry of this particular formula, and also different mass to charge ratios are provided. We have to select which one is the incorrect one. Okay, let's get started for this. So in question, the data provided is this, that the molecular formula for nitrogen trichloride is NCl3, and in question it is clearly stated that the nitrogen is only nitrogen 14 and chlorine exists as what, chlorine 35 and chlorine 37, that these two isotopes. So let us check for all possible molecular ion combinations. So first one given is this, that is nitrogen and chlorine 35. So there are three chlorine 35. So if we calculate the M by E value for this particular option, then we will have 14 plus 35 plus 35 plus 35. So the sum is going to be 190, which exactly matches with the value given in the table. So this means option A is correct, but we have to determine the incorrect option. Okay, so let's go for the next one. So in the next option, we are provided with nitrogen and chlorine 35. So there are two atoms of chlorine 35 and one atom of chlorine 37. So if we follow the molecular formula given, this is the M by E ratio that we will end up with. So we see that we are ending up with 121 M by E ratio for this particular option, which absolutely matches with the option given in the tabular form. So let's go for the next option, that is this one, where we have one nitrogen, one chlorine 35 and two chlorine 37. So if we follow the same molecular formula, we will end up with the M by E value as 123. So we see that this option 3 is also correct. So till now we have understood that option A, option B and option C, these three are correct. So let's check for the last one. So here we have NCl2. So from the molecular formula itself we can make out that this is incorrect, because for nitrogen trichloride the molecular formula is NCl3, but still let's check it out. So when we check for this one, we see that the M by E ratio, which is coming as 88, which doesn't match with the value given in the table, because if there is one more additional chlorine given, then only it is going to be 135. Okay, so this means that this option D is incorrect. Hence you will mark the correct answer as what? Option D. So this is how you're going to solve this type of questions. Now the question 4 is, what information can be determined from infrared spectrum of a molecule? So these are the options that are given. So they're asking whether we can determine number of hydrogens from the IR spectrum, or the number of hydrogen environment, type of bonds present, or the relative molecular mass. So let us understand this with this theoretical part behind the IR spectrum. So when we talk about IR spectrum, it is nothing but the absorption region, okay? And it shows absorption of different types of covalent bond. Okay, so it completely shows the different type of bonding which is present in the given molecule. Okay, so in conclusion, we can determine the different types of covalent bonds, different functional groups using IR spectrum. So it is clear that we cannot determine the number of hydrogens, we cannot determine the number of hydrogen environment, we can determine the type of bonding present, and we cannot determine the relative molecular mass using the IR spectrum. So it is clear from the explanation that the correct option is C. Now let us understand why other options were incorrect. So when we talk about option A, so the option A was given as number of hydrogens. So number of hydrogens, we do not use IR spectrum in order to determine the number of hydrogens. Instead, we use combustion analysis. What do you mean by combustion analysis? Well, here we burn the given substance to determine the carbon and hydrogen by the evolution of carbon dioxide and H2O after the substance is completely burnt. So depending upon the amount of carbon dioxide and water that is getting produced, we determine the number of carbons and hydrogen present in that particular compound. So we do not use IR for this particular reason. Now the next option was this, hydrogen environment determination. Well, for this one we use NMR spectroscopy. We will be studying about all the spectroscopy in detail in further sessions. Now the next option D, relative molecular mass. So we do not use IR for determining relative molecular mass. Instead we use mass spectrometry, not IR. Okay, so this is how you should know which spectroscopy is used for what. Okay, because if you're aware of it, then only you will be able to answer such type of questions. Now the next question is, which of the following bond will produce the stronger absorption in the infrared part of the electromagnetic spectrum? This is very easy question. You should know only one thing. That is this. That is, whenever we talk about IR absorption, so only those bonds which have changing dipole shows the IR absorptions. Okay, symmetrical and non-polar bonds do not show IR absorption. So when we look at the examples or the options which are given over here, we see that we have oxygen oxygen bond, we have carbon nitrogen bond, and we have carbon oxygen bond. So we can clearly see that in case of carbon oxygen bond there is dipole. Okay, there is dipole which is induced because of the difference in the electronegativity of these two atoms. Even in case of carbon and nitrogen, we see that nitrogen is very electronegative compared to carbon, and hence there is a dipole which is induced. But in case of oxygen oxygen bond, both of them they have same electronegativity, due to which they both are not showing presence of any dipole. Hence this bond will not show any absorption in IR spectrum. So if we follow this theory that we have understood now, then the correct option will be B. Why? Because only carbon and nitrogen bond and carbon and oxygen bond will show the IR absorption. Oxygen bond will not show the absorption in IR because it is a non-polar bond. Now the next question is, which of the following cannot be obtained from an infrared spectrum? So option A is the molecular mass, the presence of C double bond O bond, the presence of OH bonds, the identity of the compound through the comparison with other spectra. Well, we have studied just now only in previous slides that infrared spectrum is used to determine the different types of bonds. Okay, especially we can determine these functional groups, okay, different types of functional groups, different type of bondings using IR spectrum. Even we can compare our data with the existing data to determine what kind of compound we have. So this means we can use it to compare with the other spectra that we have to confirm what compound we are having with us. Okay, so this means we cannot determine the molecular mass. We can determine the presence of carbon bond, we can determine the presence of OH bond, and also we can compare the data to determine or to identify the compound. So this means the correct option is A, because this is the incorrect one. We cannot determine the molecular mass using IR spectrum. So with this, we have completed our session. I will also be posting more questions based on such topics, which will help you to prepare for your exam. Hope you have understood everything. Do like, share, and subscribe to my channel, Artistic Atom. See you in the next session.